Okay, let's talk about scenario number 3. This is gonna be the same network topology that we had the same three devices, R1, R2, and R3 with two different networks, and R1 is to see R3 and vice versa using static route. So the difference between this scenario and the previous two is about the storytelling in plain English is different, but the whole concept is the same. It is explaining the network topology, and I just name it as router and the connection details. Let's go ahead and check in our environment. The server is running over here, the simulation is empty, and all we need to do is to run the code to test the system with scenario 3. So as expected, when the code is running, we see this welcome message, and it can help you to generate the live and interactive network topology from plain text. Please paste your scenario in below, which in this case will be scenario number 3. I'm just gonna go ahead and copy that and paste it over here, hit the enter, wait for the system to extract the structure command string out of this scenario, and after that the key value pairs and provisioning to the simulation. Beautiful. What is happening? The PyAuto GUI is trying to log into the EVNG, and Selenium is creating the devices, creating the links between the devices, and starting each device. And as expected, the telnet session for each of these devices is opened separately in new Windows tab for us to follow the configurations in the screen. Yeah, so the first one is our network topology, R1, R2, and R3. Beautiful. We just keep it on the side of the screen and our code on the left. We need to wait for 90 seconds. As we know, I just explained that these images of the routers are real images, and in real world the image takes like 1 minute to 1.5 minutes to boot up completely. That's why we just gave this freezing time for the image to be booted up completely. Meanwhile, we check on our structured command string. System understood this scenario, parsed this structured command lines, and after that generated the key value pairs. You can see like device 1, the type and the name, all those parameters, 2 types of configuration, basic and static route. For the device 2, you can see device 2 doesn't have L3 config, it is empty. Device 3, almost same as device 1, it has its own belongings for basic config, static config, you can see, and these connections for the L3 parts we need. Let's go to R1 because the telnet has been initiated. Telnet to device 1, please wait. We just give it a little bit of wait and then start pushing the configurations. Okay, so the configurations just started. We start with basic configuration. It should be started by now, yes, and hostname, interfaces, L3 configuration should be the next, and static route, as you can see on the right side of the screen. So static route is configured to the R3 over here. So telnet to device 2, initiated, please wait. Let's open the R2 and wait for the configuration to be generated and pushed. Okay, it seems it started. Starting with basic configurations, It's going to be our hostname interfaces, and there's no L3 config on R2 because R2 is a bridging device between the R1 and R3. So that's all about it. Two interfaces are configured. One leg is to 192.168.0.0 and the other 100.0 networks. And these are the interfaces. Completed. Telnet to device 3 is initiated and it's in the waiting phase. Let's open up the terminal for R3 and see what is going on in here. After a little bit of wait, the configuration should be started. Here we go. Starting with basic configs, hostname and interfaces. After that, L3 config, which is our static route. The static route is to R1, so we can see the 0.0 over here. And we are running a test. How we can test the reachability using a ping. We're pinging R1, and fortunately we're getting a success rate of 60%. And that 60% is because of the address resolution protocol, ARP. The first time it was sending, the packet was lost. If we do it one more time, because the ARP table is populated, we can see 100% reachability. Just to make sure, we ping the R3 from R1. We're gonna have one packet lost because of the ARP, and the second should be 100%. Here we go, and this is our interactive scenario, interactive network diagram as expected. And that's all about it from scenario number 3.